video, we are going to see how to apply some of the differentiation rules. The first one, power rule. If you have expression in this form, it's going to be like this. Let's see example to see how this works. Example. If you have, for example, x cubed, the derivative is going to be n is 3. So you have n from here times x n minus 1. So I have 3 times x squared. So that's all. Usually what I do, sometimes what I do is like x to the power 4. Derivative is going to be, I just say, okay, I'm going to place 4 multiplying x, and then on top, I get the number that comes before 4. 3, like that. Let's see another example. So you have x to the power of 1 over 2 equal 1 over 2 times x 1 over 2 minus 1. So I have 1 over 2 times x minus 1 over 2. That's all. Another example. Let's see x derivative is the same as x 1 over 3 derivative. Then I have 1 over 3 times x 1 over 3 minus 1. I get 1 over 3 times x minus 2 over 3. So that's how you apply the power rule. Let's move to the second one, the constant multiple rule. Basically what this rule says, if you have a number that's multiplying a function, you don't find the derivative of the number, just find the derivative of the function. Let's see in the example. It's better to understand with example. If I have y equal to 2x to the power 4, I want to find the derivative y prime equal to 2x to the power 4 prime. This rule says that the 2 can come out since it is multiplying, and I just have x derivative, x to the power 4. Then I have 2. I just find the derivative of this, which is 4 times x, 4 minus 1. Then I have 8x cubed. So that's all basically what it says. Like you take the number out of the derivative and then you apply the whatever rule you end up with. For example, x to the power 6 divided by 3. Then I have derivatives divided by 3 prime, in this case, 1 over 3. This is the same as 1 over 3 times x power 6, like this. Then I have the 1 over 3 can come out, x power 6 prime. Then I have 1 over 3, 6, x to the power 5. Then I have 6 divided by 3 gives you 2, x to the power 5. Now, let's move to the third rule, sum and difference rule. So basically what it says, if you have two functions adding to each other or like subtracting, you just find the derivatives separately. Let's see example to better understand this. So from here, actually from this section, you are pretty much using all the rules with some new adding them together. So you are just mixing them as you become a pro in derivatives. Let's see, I have y equal to x to the power 4 plus x cubed. So this is just saying that derivative of x to the power 4 plus x cubed prime, in this case, I can just separate since it is addition. I have x power 4 plus x. Then I can just apply the rule, identify. I have two power rules, right? So I can just apply, I have 4x cubed plus 3x squared, like that. And that's all. Let's see another example. For example, x squared plus 2x minus 3 plus 7. Derivative of this, I can just separate x squared prime plus 2x cubed minus x cubed prime plus 7 derivative. Then here I have 2x plus here I have 2. 2 can come out. Derivative of any number, I forgot to mention, it's very important. Derivative of any number is 0. 0. If you actually forget, then just remember that this 7 times x of power 0 derivative, right? The 7 can come out. I have x of power 0 derivative. Then if I apply 7, 0 times x, 0 minus 1. So I just have 0. So, right? So just remember, derivative of any number is 0. Is 0. So I have 2x plus 2. Derivative of this is minus 3 minus 1. So I have 2x minus 6x minus 4. So that's how you apply. And then last one, if you have y equal to, let's say, 1 over x cubed minus x to the power 7. X cubed minus x power 7 prime. Then I have x minus 3 prime minus x to the power 7 prime. Here, just apply the rules. You have minus 3, x minus 4, minus 7, 6. And that's all. So that's how you apply the sum and difference rule. Let's move to the next one, product rule. Product rule. Okay, if you have the product two functions, then you can pretty much, the first way, you can just multiply the two functions and then apply the rule. But sometimes it's really hard to multiply them, so we just apply this rule here, which is the same as writing this way. So you have, it's going to be derivative of the first function times the other function non-derivative plus the first function non-derivative times the derivative of the second function. Okay, let's see that in practice to better understand. We have example x times x squared plus 1. Plus 1. You can do it in two ways. One way, if you can just multiply x cubed plus x, then you apply the derivative. Derivative is going to be x cubed plus x derivative. Then I have y prime equal to x cubed plus x derivative. Y prime equal, here is 3x squared plus 1. Derivative of x is 1. Now, I can also use the product rule, because sometimes you have, here it was easy because it was just x. Imagine that you had x plus 4, x plus 5, then okay, it takes a lot of time to do the multiplication. Let's see using the product rule. Y prime is going to be the first function derivative, the second function non-derivative, plus the first function non-derivative and the derivative of second function. Like that. Then derivative of x is 1 times x squared plus 1 plus x. Here I have addition, so I'm going to have x squared derivative plus derivative of 1. Then y prime is x squared plus 1 plus x times, here I have 2x, derivative of any number is 0. So I have x squared plus 1 plus 2x squared. I have 3x squared plus 1. So it is just the same. So why using this rule? Imagine that if you had, I'm going to leave, you can try this example. Imagine that if you had x cubed plus 2x times x squared plus 2x, for example, like this. If you were to multiply everything and then do derivative at the end, it takes a lot of time. So you can just apply the derivative now, and then at the end you just simplify the answer. So that's the product rule. Let's move now to the last one that we're going to talk in this video, the quotient rule. So basically they say if you have a division of two functions, you can just do like, okay, the first function, derivative, and so on, the way you see it. Let's see example to see how it works. X minus 1 dividing x plus 2, derivative. Okay, u is the function top and v is the function at the bottom. So we have x minus 1 prime times x plus 2 minus x minus 1 times x plus 2 prime dividing by x plus 2 squared, like this. Then I have this addition of two functions of x and the minus 1. Derivative of the first one, x, gives you 1. Derivative of 1 gives you 0. Multiplies x plus 2 minus x minus 1. The same here, derivative of x is 1, derivative of 2 is 0. Dividing by x plus 2 squared. Then I have x plus 2 minus x minus 1 divided by x plus 2 squared. Then I have x plus 2 minus x plus 1 x plus 2 squared. Then you have 3 over x plus 2 squared. Just like that. So that's how you actually do derivative quotient rule. So you just have to remember all of this rule that we studied, and you just place all of them together, and then you're gonna be pro in derivative.